Hi guys, nice to have you back. Today a new episode straight from my little workshop. And what's here in front of me is something I've really been waiting a long time for. Because in here are the first laser parts for the Bis Rexx. This means that assembly is finally underway. It's taken a long time, much longer than I expected since the presentation video, but today is the day. And we'll have a look at which assembly group we start with in a moment. But why am I wearing these strange glasses? Well, as much as I love my little micro TIG welder here, and I really have spent many hundreds of hours with it, but I think a project on this scale requires different equipment. That's why I've fulfilled a wish I've had for a long time, and I treated myself to this one. This is the handpiece from my new laser welder. In other words, this part is being welded together properly. And the glasses? Well, I'd rather not trust the nonsense that came with them when it comes to my eyes. That's why I got myself a decent pair of glasses, especially as this thing doesn't work with normal glasses underneath anyway. But let's see what's in the box first. Okay folks, let's take a look at the individual components and how the whole thing comes together, starting with the main frame. And by the way, if you're wondering what this is all about and what it's supposed to do, this is the project start of my new model. I've already made a video about it where I introduced the prototype. I'll link you to the video in the top corner here. Or here we'll have to have a look in one corner, in any case. And today I just want to show you what the first assembly looks like. I want to start with the body of the model. It's going to be a transport vehicle. And with that, we can see how big the whole thing will be. Back to the laser parts. So the main frame, this is where these reinforcements come in. Not this one, but this and this. Then the main part of the trough goes on top. The colleague here. The sides are fitted with drop plates to make the whole thing higher. This is the front wall. It goes in here. There's a small final break at the back. That goes there. And last but not least, a part that sits above the cabin at the end. That goes here at the front. And I think when we look at it, it's going to be quite a big thing. And just as a comparison, this here is a standard 1/14.5 scale roll-off body, which I think will fit a bit more. Incidentally, the components are all laser cut from stainless steel. That means the thing will be really robust. And by the way, I based the design mainly on the video I showed you when I presented it to you. That means, of course, that unfortunately there is no original caddy that I could use. And everything has been recreated to the best of my ability using the videos and pictures of the prototype. But I think we're getting relatively close. Before we start welding the model, I would like to briefly show you how laser welding actually works and what setting options we have. Let's start with the basics of laser welding. So this is the handpiece of the device. The laser light comes through here, is bundled in here, and it has the focal point here at the front, so to speak. Incidentally, the device is not yet switched on. We're doing this as a dry run first, because the fans of the device are relatively loud. And then you won't understand anything anyway. Incidentally, you can change the attachment here at the front, depending on what you want to weld. There are different attachments. And as you probably know from other welding processes, you also need a shielding gas so that the weld seam does not oxidize directly. I now use argon here, but it should also work with nitrogen. Argon simply because it was just there. I will try nitrogen next. In any case, we also have one of these clamps here for safety. Compared to other welding devices, I'm thinking of TIG, for example. It's not there to ensure that a current actually flows through it. The clamp only detects if you actually have the device on the workpiece. This means you don't need a really good contact, so not much current flows through here. It simply checks whether you have the gun on the workpiece or whether you are trying to shoot through the air. Unlike with other welding processes, I don't have any filler material here at the moment. We could use a wire here, but that will come later. But I don't have this extension at the moment. This means that at the moment we can only weld without filler material. This means that the parts we want to weld must really be butt to butt. There must be no air gap in between, otherwise we simply won't be able to get it together. Another thing that is different from other welding processes. Apart from the fact that we weld with light and not with electricity, is that we can set the width of the laser spot that hits the material. This means that I can focus it very strongly so that it only hits one point. I could also use it to cut material, for example, but I haven't tried it yet. But it should work. That means we can weld and cut with it. But back to the topic. We can also adjust the width. It's supposed to go up to 5 millimeters, but I haven't used it that far yet. I've always welded with a width of around 0.5 to 2 millimeters, but I'll show you an example of what that looks like in a moment. I have prepared a few test sheets here, which are also stainless steel. The sheets are not additionally cleaned, just as I had them in the drawer. The base here is aluminum, we can't weld through it, and I'm going to connect the clamp here at the back so that we don't have to connect it directly to the part, but can simply place the components on it and then weld them. The first time I welded with a handheld laser, I was really skeptical about how such a small spot could make a proper seam. The little red dot you can see there is not the laser itself, but the aiming aid. Without it, it would be a bit like playing darts blindfolded. Before I really get started today and weld the sheets, we first try out different weld seam widths. I start with 0.5 mm, then 1.5 mm, and finally the full 5 mm, just to get a feel for how wide the weld seam could be. The first seam at 0.5 mm goes so quickly that I almost missed filming it. The laser literally melts its way through the stainless steel cleanly and almost silently. I admit it, I'm still really impressed. At 1.5 mm, it gets wider, logically. But the heat input also changes. If you're not careful, the thin sheet will warp. I've already learned that the hard way here and there. Last but not least, I'll show you the 5 mm width, or simply the largest setting I can choose. That sounds fat at first, but it's not really such a wide beam. The laser dot wobbles, as they say. It dances back and forth at lightning speed, which creates the wide seam. I have greatly reduced the speed here, so that you can see it better. You can probably see in the picture how the dot moves back and forth. Now, let's continue with two sheets that I really want to weld together. As with all other welding processes, it's a good idea to spot weld the sheets together first, so that they can no longer move relative to each other when it really starts. To get a really clean, straight seam, I use another piece of metal as a kind of ruler so that I can guide the laser head exactly straight. And as you can see, the seam really speaks for itself. Of course we have a bit of distortion here. This is exactly the same as with all other welding processes. Of course, I could have avoided this if I had placed a few points on the other side first. In this particular example, however, the sheets can still be aligned quite well by hand, but it's definitely something you should pay attention to later. I'll just weld again from the other side to see how stable the whole thing is when there are weld seams on both sides. Again, I used the ruler and simply pulled it through cleanly and evenly. If you look closely, you can also see the individual lines in the weld seam where the laser has moved back and forth. This can be avoided by increasing the sweep frequency, i.e. the speed at which the beam moves back and forth, even further. This makes the weld seem much more even, but as you can see, I can no longer break the sheet metal with my bare hands. But now enough theory, and let's get started with the assembly. Before I start using the laser, I want to make sure that the components stick together really well. To do this, I use the small micro TIG welder that you saw at the very beginning to fix the parts together. If you're not yet familiar with this type of device, the process is actually exactly the same as for normal lap welding. In other words, you have a tungsten electrode. The main difference, however, is that you don't create a continuous weld seam, but more or less place individual points one after the other. If you can see this immediately during welding, the electrode is retracted just before the spot is created, so that you don't get stuck in the weld pool. The device only starts the welding process when the electrode touches the component. This means that it checks whether current is flowing, and then automatically sets the welding spot after a short time. Here too, as with other welding processes, it is important to have a steady hand, so you shouldn't really work under stress. For me, it's now almost like meditation. It's a great way to relax and just concentrate on one thing at a time. If you're wondering whether you need safety goggles or something like that, yes, but it's not a classic welding helmet. It's a magnifying lamp with a built-in shutter. This means that the lamp or magnifying glass through which you look automatically darkens just before the spot is reached so that you don't get the flash of light in your eyes. Here's a quick look at the electrode. We weld with a 12-volt tungsten electrode, and with such small sizes, it is all the more important that the electrode is properly ground. As you can see, the welding machine is also minimalist in size and adapted to model making. If you're wondering where the parts are actually installed in the model, these are the cross struts that sit underneath the trough. So we first build this rib that sits underneath here and marry it to the folded part of the trough at the end. Let's take the opportunity to take a quick look at the movie that I used as the main model for the model. This is the movie, from the introduction video. You can also see on the underside of the original that there are exactly these cross ribs, and we are now preparing them. With the prepared parts, it's finally time to go to the laser. I place the parts on the aluminum base and carefully draw a continuous weld seam with the laser. Is it necessary here? Certainly not. The small wig welding machine would have been perfectly adequate here, but hey, if you have a machine like this, you have to try it out. And when I look at the weld seam, it really looks like it was done by a surgeon. I'm really looking forward to seeing how it works with the larger parts. Let's try it out together. I repeated the whole thing a few more times, and now it's finally time to assemble several parts. I connect the 5 crossbeams with the longitudinal struts, and this results in the rib that goes under the trough. The parts are a bit tight and have to be bent here and there. But that's nothing that can't be solved with the parallel pliers. Once the individual components have been tacked together, the rough structure is already complete. What is still missing now is to weld everything cleanly. I really tried a lot to find out how I could weld this unwieldy part properly. And as with all other welding processes, it turned out that good preparation is the be-all and end-all here. The easiest way was to clamp the entire frame in the vise so that it didn't move back and forth. In this position, I can then pull through the weld seams between the individual parts relatively easily. Here, by the way, with slightly higher power, because the material thicknesses are now also somewhat thicker. I quickly added a few unnecessary but authentic details at the end of the skeleton. But I'm not here to make life easy for myself. Let's do a few meters now when it comes to parts. Next up is the folded main sheet from the trough on top of the rib, which we have prepared. Incidentally, the sheet is 1.5mm thick, and admittedly, it is considerably larger than it looked in CAD. But now there's no turning back. I first tack the parts together again with the micro TIG, so that I can then weld through everything with the laser. And as nice as laser welding is, sometimes it doesn't fit in the end. With minimal distortion and perhaps a little too little play between the individual parts, it is then not possible to connect the flue to the main body without further ado. But no problem that my good friend Sergeant Big Clamp couldn't solve. We took a short break, discussed the problem, and relatively quickly came to the conclusion that a bit of pressure and persuasion was required. So we quickly applied the clamp and tightened it. We immediately identified the next challenge. For reasons, the inner carrier is slightly flatter than the outer one, which means that both cannot be tightened at the same time with the clamp. But here too, a quick solution to the problem. Simply take a few other parts lying around, level out the height, and Sergeant Big Clamp can press both beams cleanly onto the trough at the same time. And as helpful as the support is, it is a little unwieldy in this situation. For this reason, we decided by mutual agreement to only tack here for a short time, and to go our separate ways again later. This is a good time to check how far we have actually got with the welding. The easiest way to do this is the internationally recognized gong method. It works as follows. Simply hang the steel structure at one point if possible and hit it firmly. If something rattles now, you know for sure that there are still parts that are not properly welded together. But this is also logical, because all the side arms have not yet been welded and we have only briefly spot welded the base frame. And there is still a lot of rattling, so let's get back to work and weld everything properly. To give you a good idea of how long laser welding actually takes with continuous seams, here are a few more shots at the original speed. It's really fun, I have to tell you. And what I've noticed, especially in the less accessible areas, is that you can also push the weld seam really well. It is somehow the first intention to always pull the gun, but pushing works just as well. What is still missing are the arms that go outwards. And here you can clearly see why it has just rattled so much. There really is still a clear gap to the folded part. But everything can be bent nicely by hand, and so we can weld it together quickly. But as precise as the laser is, it can't get into every corner. And so, in the end, it's the combination with the micro-TIG that does it for me. So I quickly ground the electrode and added a few more points. And to give you an idea of the size, here's another close-up of the micro-TIG weld seam with the 1mm electrode. And as a size comparison, my hand, which isn't that big. The last part I really wanted to get done in this session is the small plate that is welded to the rear of the trough. In terms of the edging, it's the same as the large tub, so it should actually fit quite well, right? So first of all, we set to work and briefly spot welded with the micro TIG so that we could align the parts properly. And here again, a bit of pressure, but this time from Sir Hammerlot. Here you can see the strength of micro TIG again. Simply align the parts by hand and tack weld briefly. I would definitely not hold out my hand when laser welding. What did I say about gaps and laser welding without filler metal? I can't really remember, but I think it was something like, that doesn't work. But it's better to double check. I already have the welding rod. Let's just stick it in the gap and see what happens. Maybe it will work then. And what can I tell you? Of course, it would have gone much better with the right add-on for the welding machine. By the way, I hope I'll have the extension by the next time so that we can weld the other side properly. But people are notoriously impatient. And last but not least, I only owe you one more thing. Of course, you've all been waiting for it. The gong test. Let's see if anything still rattles around here. And at this point, it's certainly a good time to end this session for today. I don't know about you, but I'm really keen to continue building this thing. And what I particularly like here is the way the weld seams on the top of the trough stand out. That will certainly look really good when it's painted. At the end, there are a few more shots of the weld seams in detail and a comparison with the original in the video. Let me know whether you think I've done a good job on the original or not. And anyway, what did you think of the videos? It felt like it was quite a mess at times. The tripod was constantly in the way. The GoPro on my head too far away. But let me know what you think. And last but not least, as always, please leave a subscription, free for you and super motivating for me. See you next time.